There is nothing that goes better with exponential and logarithmic functions than Dunkin' Donuts coffee. It is the true mathematical something. Someday I'm going to be making millions from Dunkin' Donuts and all my amazing commercials. Until then, I'm just going to keep making math functions. By the way, just as you saw in my opening video, all this information can be found at www.nkinfinity.com. N stands for Newman. K stands for Krause. Just in case you want to know where Newman is, who Newman is. This is Miss Newman. There she is. Hi, Miss Newman. And there I am, Mr. Krause. Yes. How about them glasses? Those glasses look awesome. Miss Krause, Miss Newman. All right, here we go. By the way, just in case you're wondering, yes. I love logarithms. They're so much fun. Oh my gosh. By the way, I just updated to the new version of Windows 10 something or other, some big update on August 2nd, so hopefully everything goes smoothly today. Let me see, am I still recording? Still recording. Calculator still works. Yay! Wait, maybe it doesn't. Okay. So let's get going. Ooh, I just burped. Sorry about that. All right, say warm-up would be in class. It'd be with a calculator, so we'll just kind of do this together. But you do need to show your substitution. Even if it says this work, you need to show what you're doing. So what we're really doing is f of 0, because that's what I want to find. So all we're going to do is plug in the 0 in for x. I'm going to tell you right now, already the new Windows, my writing is better. I don't know if it's cleaner or smoother. I'm not sure what's going on, but it is a little bit better. So I could go to my calculator and be very embarrassing to type this in. Oops. Okay, and type in e to the 0 because it's just 1. And everybody knows that anything raised to the 1 power, or 0 power, is just 1. So we're going to do this one. Log base 3 of x equals, we don't know. So we're going to plug in, this is x. So we're going to plug in 1. So h of 1 is equal to the log base 3 of 1. What does that equal? Remember, this is the exponent that I need to put on the 3 to get 1. What is the exponent? Because that's the definition for logarithm. What is the exponent I need to put on 3 to get 1? And based on what we did here, you're probably thinking 0. At least I hope you are. But if not, we just come over here, control log base 3 of 1. And we get 0. So in that case, h of 1 is 0. Moving on. H of 3. So we're going to do g of 3 is equal to 2 to the 3 minus 1 plus 3. We don't need our calculator. We don't need our stinking calculator. This is 2 squared plus 3, which is just 7. 2 squared is 4. Oh, we just got done with about a 6 or 7 mile bike ride. I'm starting to sweat. We'll get done. All right, let's get rolling. Let's get rocking and rolling. Let's just dive right in, right? You want to be able to impress your friends. You know, you're going to be at a date some night, and you're like, you know, honey, let me show you how I do exponential and logarithmic functions. And she'll be like, wow. Or if you're a girl and you show the guy how to do exponential functions, and be like, ooh, man, you are hot in math. That's such a good thing. Maybe. But it's going to make you money someday. Okay, let's get going. By the way, never, ever, ever quit on your dreams for any other person in life. We want to figure out, so you guys need to figure out, okay, here is x. Whatever's in these parentheses gets placed in there. Whatever's in those parentheses gets placed in there. So right now, I've got j of x plus 6. So what I want to do is j of x plus 6. So now that's the thing that's in the parentheses. So that's what's going to get subbed in for x. So now it's 2, and sub in using parentheses, please, of x plus 6 minus 1. Hey, wow, that was a tough problem. Moving on. Okay, again, whatever's in here goes in for x. So I want to do k of x squared plus x. Well, that's equal to the natural log. Normally we do it with a cursive L, just because you know it's a natural log. If it looks like that, it's too much like a 1. So just be careful. Natural log of whatever's in parentheses. X squared plus x. 'Tis all, kids. I'm not trying to hurt you yet. You haven't impressed your friends yet, but you're going to today. Today, they're going to be impressed. So I want to find m of x cubed minus 4. So that's equal to 5e. Now, whatever's in here goes in for this. X cubed minus 4. All I'm trying to do with this simple stuff is just get rid of some of those fears. Get rid of them craziness. You know, you guys know how functions work. You've been dealing with them all year long. You know how they work. This is nothing different. This is simple stuff right now, okay? It's going to get a little funky and crazy soon. All right, so we're going to do q of 7x minus 1. Now, x goes in here, but x also goes in here. So our new function, or what our evaluated function of that, which I guess in this case is going to be called r of x, is equal to q of 7, which is equal to the natural log of 7x minus 1 all over 7x minus 1. Now, some moron's going to want to cancel those things. Don't. This is natural log of this thing. You can't. That's like one big thing. You can't cancel the 7x minus 1s. That gets you hurt in my class. Come by with a big, large stick. Start smacking around at you. You're wondering how I still have my job. I'm kind of weak. I don't hit that hard. All right, so this one looks, what's going on? Oh my God, there's so much going on right here. I don't understand. What is w of x? W of x is defined as u of x over 3. So we're going to figure out what u of x over 3 actually is. So everywhere we see an x, we're just going to plug in x over 3. So this is 1/2 the log of x over 3 minus x over 3 squared. Now, quite honestly, if I'm writing this out, so w of x, which is equal to the u of x over 3, is equal to 1/2 the log of x over 3 minus, now what is this? It's really x minus 3 times x minus 3, which is x squared over 9. Either one of these answers would have been acceptable. Moving on. Moving on. Oh, no, Mr. Krause, that looks crazy. I don't know if I can do it. All right, here we go. I'm going to do it in a green color. That's how easy it is. V of e to the x. So whatever's in here goes in for this and goes in for this. So it's e to the x squared plus 2 times e to the x plus 2. Now, it's really not good enough to leave it like this, because what happens when you have an exponent raised to an exponent? Oh, yeah, that's right, John. You multiply them. So it's e to the 2x plus 2e to the x plus 2. I don't know why I was writing equals. Plus 2. And there it is. All right, so that's just simple substitution. Not a big issue right there. Not bad. You guys can handle that. Oops, wrong one. Solving exponential and logarithmic equations. You see how fancy we made that font? That's so it makes it sound so festive and fun. You ready? It helps, kids. Logarithms, you know, when I drink Dunkin' Donuts coffee, logs come really simple to me. All right, you guys ready to rock? Here we go. Let's take this example. And we talked about this earlier. Remember, I said I really want to make sure that my bases are the same. Now, I could make them both 4. I'm going to do this 2 different ways. I want to show you that for those of you that's smart and you want to, you can always make it 4. I like using the bases 2, 3, or 5. If it's even, use 2. If it's odd, use 3. If it's got a 5 in it, got a 5 in it. And you'll know in it. It's 25, 625, 125, 6125, 3125, all these crazy numbers. As long as it's got a 5 at the end, it's going to be 5, okay? But I'm going to do this one the way I like to do it, and that is changing them all to 2. So 16, 2, 4, 8, 16. So that would be 2 to the 4th, and what was already there? X is equal to, what's 4? It's 2 squared, but what's already there? X plus 1. Oh my gosh, get off my screen. I got you, get off. Sorry, I just updated. Oh my gosh. And I got new Skype apparently, but I don't want it right now. So let me get rid of it. All right, so when the bases are the same, we just simply set the exponents equal to each other. So 4x is equal to 2x plus 2. Subtract 2x, I get 2x equals 2, or x equals 1. So that's one way to do the problem. Another way to do the problem is I can change these both to be 4. So for example, 16 is 4 squared is equal to 4 to the x plus 1. Okay, that works. Now the bases are the same. I set the exponents equal to 2 is equal to x plus 1. Subtract 1, I get 1 is equal to x. It was faster, but that only works when you have a multiple of 2. If I gave you something like this, 2 cubed is equal to 6 to the x, you couldn't do it that way. Okay? Actually, you couldn't do it either way. But 2, 4, I would just use 2, 3, or 5. It's just generally it's easier. But as long as the bases are the same, it doesn't really matter. Whoa, whoa, oh yeah. So what if I said this to you? I said, okay, child, 5 over 10 is equal to x over 10. Would you tell me that x is equal to 5? What if I said 7 times y is equal to 7 times 8? Would you tell me that y was 8? Sure. What if I said f of 5 is equal to f of x? Would you just say x is equal to 5? And that's what's going on over here. You'll notice I have log of something is equal to log of 5. Well, the logs are the same. The log words, those are the same. So as long as these two are the same, we're actually in good shape. So I just have to set those two things equal to each other. 2x plus 3 equals 5. 2x equals 2, or x equals 1. Now that's true when you only have log equal to log. That's not a bad case. Or when I have bases that I can make the same. That's not always the case. Oh, look at that, a bit more complicated. These do not have common bases, so solving involves changing the form. Let me remind you from yesterday. What color you want? Green? Green would be ugly. We're going to go black. Yesterday we talked about the fact that 2 cubed is equal to 8. And when we change the form, it's all about that base. In my class, you will hear that Meghan Trainor song until you want to puke. We will play it over and over and over again. When kids come in, oh yeah, it's all about that bass. It's playing. When they leave, I'll turn it back on. And sometime in the middle of class, while they're sitting there doing work, I just jam it up, play it as loud as possible. Makes every single one of my neighbor teachers mad. I think I need to stop. I'll be right back. Oh, no, I don't. I can finish this. So anyway, how do I get rid of you? So it's all about that bass, about that bass. Oh, it's all about that bass, about that bass. That's what you want to remember when you're changing the form of a logarithmic function, or you're changing the form of an exponential function. So if it's all about that base, I come over here and I say, okay, my base is 2. when I write a log function, it's log, and I got 3 places to fill. 1, 2, 3. It's all about that base. So I want you to start with the base. The base doesn't change. If the base is here, the base is here. It becomes a 2. And then these 2 things switch. That's it. I'm changing it, so I have to change something. So I'm going to change it from an exponential, all about the base, but instead of 2 cubed, it's now 2, 8 equals 3. We're going to get some practice with that. That's how you change the form. Now, before I solve these practice problems, let me take a little break. If only they drank coffee, they would be better at logarithms. Oh, you're back. I always get talking to my coffee when I take those breaks. Let's get going. All right, so here's how it works. Logarithms and exponentials are inverses of each other. So in order to solve a logarithm, you need to change it to an exponential. In order to solve an exponential, you need to change it to a logarithm. It's as easy as that. Okay? Now, do you remember log? When I write the word log and I use log functions, the base goes here, something goes here, and it equals something over here. What happens when this piece is missing? Remember, we called that the common log. And you're going to see when you're dealing with common log that this 10 is missing. It's not there. So you're just going to see log of something, and you have to remember, oh yeah, the base is 10. So let's see how we got. It's all about that base, all about that base, that base. So when you're dealing with logarithm and exponential functions, the first thing I want you to focus is on what is the base. Now in this case, that's why I mentioned it, the base is missing. So you have to remember, oh yeah, my base is 10. This is this is a logarithmic function. We're going to transform it or change it into an exponential function. Now, the way we change it into an exponential function is all about the base. So we're going to write the base down. And remember, we have to change it. So if we got to change it, right now I've got 10 with my x. Notice they're going to switch sides. So instead of 10, 10 has to be a base. 10 to the 10 equals x. Oh, x is equal to, what is 10 to the 10? Holy crap, that's like my salary from last year. Let's see what 10 to the 10 is. 10 raised to the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Definitely my salary. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's sloppy. Well, let's do 9 backwards. 0, 1. Here are the thousands. Here are the millions. $1 billion. You could always write 1 times 10 to the 10 equals x, or 10 times 10 to whatever it is. I would just write it like that. There it is. $1 billion. All right, that one's kind of boring. Here we go. This one's going to be knucklehead as crazy. So this is an exponential. I need to turn it into a log function. And I don't know if I've said it yet or not, but it's all about that base, about that base, about that base, about that base. I know, Megan Trainor, you're jealous. You're jealous of my sick lungs, my ability to make jokes at mathematics and have fun with it. Oh yeah, I know you're jealous. Thanks for making that song, by the way, Megan Trainor. I appreciate it more than you can imagine, because I use it all the time in class to get my kids motivated about logarithmic and exponential functions. You guys motivated? Motivated? So anytime you're on the dance floor, girls and guys, and you hear all about that base, you start thinking about exponentials and logarithms. And then you're wondering, what the hell happened to my life? Anyway, it's all about that base. So we're going to change it into a log function. So the first thing I'm going to do is write log. Now, when you write a base, write it down here at the bottom of the G. It's all about the base. There's the base, 5. Base isn't going to change. It's either going to be a base like this, or it's going to be a base like this. And then these puppies switch sides. So the log base 5 of 12 is equal to x. Now this, I just need my calculator for. Ka-ching. Control log 5, 12. 1.54, and I think it said round to the thousands place, so x is equal to 1.5, let's see, 43. Thousands place, right? So that means we're going to change the 3 to a 4. So 1.544. Ka-ching, it's done. Moving on. Now this one I can actually do two ways, and I'm going to show you that I can do it two ways. I could do this one by doing this. 3 to the x is equal to 3 times 3 is 9, times 3 is 27, times 3 is 81. So many of you, though, wouldn't know that, what did I just write 2 for? 3 to the 4th is 81. Well, x is equal to 4. Many of you wouldn't know that. So you'd say, all right, let me just do it this way. Megan Trainor's going to help us again. Thank you, Megan. It's all about that bass. A little disturbed in there, too. A little screamo. It's all about that bass. Some of you are like, okay, I'm turning you off because you're crazy and my parents are pissed. Sorry, Mom. Sorry, Dad. Man, it's fun, though. Okay, it's all about that base. So now we're going to change it from an exponential into a logarithmic. So we're going to write log. The base doesn't change. My base is 3. Base 3 of 81 is equal to x. Notice the 81 and x change sides. Boom, ba-doom, ba-doom. So now you just grab the old calculator. By the way, in German, calculator is Taschenrechner. Base 3 of 81 is 4. Done. Moving on. All right, so you should be saying to yourself, here's what you should be saying to yourself, and this is when you get allowed to talk to yourself. So if you're in math, if you're in the study hall and you're saying, you look at this problem, you say, hey, John, Mary, Jamar, take a look. It's a log function. Jamar, do you hear me? It's a log function. Yeah, I heard you. Stop telling me. Well, it's a log function. When you do a log function, you've got to change it into an exponential function. You get that, Jamar? I got that. Leave me alone. All right. So you can talk to yourself. You're allowed to do that. So it's a log function. We're going to change it into an exponential function. And you got this. It's all about that base. About that base. Anybody sick of that yet? I am. Been doing it for like 5 years. Kind of sick of it. It's all about that base. So here we go. X squared equals 4. Okay. X squared equals 4. All about the base. These switch. Well, all right. I can do two ways. I think this is probably the easiest way. Take the square root of it both sides, and then I get to sing another song to you. And you take the square root, you put a plus or minus. When you take the square root, you put a plus or minus. So I get x equals plus or minus 2. Now, wait a second. Wait a second. I learned something yesterday. I learned something about logarithms in class yesterday, Mr. Krause. This is where you get the money and you get the fame from the ladies and the gentlemen when you're like, you bust this out. You say, okay, Mr. Krause, check this out. You told us yesterday all log functions go through the point 1, 0, and they look like this. Now, unless you were lying to me, we got a problem here. Because you just said, I'm going to do log base negative 2. Negative 2's over here. I can't get there. You're not get what? Base negative 2? What does that even mean? All right, kids, you're right. You can't have a negative 2. And as a matter of fact, you should always, and I haven't done this yet, shame on me, you should always check exponential or logarithmic functions. Always check logarithmic functions because sometimes you get what's called extraneous solutions. So let's take a look at this. Control log 2 of 4. Oh, it's 2. That works. Control log negative 2 of 4. Non-real calculations. What are you doing? Reject that answer. Reject that answer. Okay. All right. I got you. Leave me alone. Okay. I get it. So the answer is x equals 2. Can't have a negative base. All right. Got to take a break. I'll be drinking some coffee when we get back. It's all about that coffee, about that coffee. That's another version of the song. It's a good one. All right, here we got a new problem. I had to take a little break before we started this new problem because I know some of you got a little scared there. I didn't want anybody getting scared. So let's use light blue because it's so nice and makes us feel better. So every time up until now, if we had an exponential, we turned it into a logarithmic. If we had an exponential, we turned it into a log, right? We have an exponential here. It is a very special exponential, but yet it is an exponential function. So, how does it work? Anytime you have E, the base E, you're going to still sing this song. It's all about that base. It's all about that base, Okay. But we have an exponential function and we're going to turn it into a log function. But. This is a special case. Do you remember me yesterday telling you about the natural log and the E button, which is the natural base E and natural base? These are inverses of each other. The only time you will use natural logs is when you have E. The only time you'll use E is when you have natural logs. So if I have an exponential function and I want to change this into a log function, which is the only way I know how to solve it, here's how I do it. I'm going to write the natural log, base E, and then these two things switch, of 4 equals 2x. Now I'm going to show you something. This is technically correct, but I want to show you something. When you go to your calculator and you type in natural log, do you notice there's no space for the E? There's no space for the E. I'm going to type in the natural log of 4 and I get whatever, but there's no space for the E. When I type in log, I got a space for an exponential. I got a space for something down here, and I got a space for something here. I got a space for something in both. But when I do natural logs, there isn't. And if you're wondering why, here's the reason. It has to be E. It can't be anything else. Just like if I write log of 5, because there is no exponential function, because there is no base there, you know it has to be 10. I don't have to tell you that. When it's natural log, when I write natural log of 7.2, this base has to be an E. I don't have to tell you it's there. Now, I will always put it in because I want you to get in the habit of when you change an exponential into a log, you think about the base. You rewrite it as a logarithm, put the base down, and then switch the x and y. All right? So I just put that in my calculator, and I got 1.3862. 1.3862 equals 2x. Divide by 2, divide by 2. So I got to come back over here, divide by 2. And I get 0.69314. So x is equal to 0.69314. 314. And I think they said round to the thousands place, so we'll say this x is equal to 0.693. All right, one last problem. All right, just as I was just saying, I don't have to tell you what the base is here. Just like on exponentials, I don't have to tell you, or natural logs, I don't have to tell you. I don't have to tell you there's a 10 here. But I think it's in your best interest to write it in. If it's missing, put a 10 in there. If it's a natural log, put an E in there. If I write to you natural log of x equals 3, you say, oh yeah, there's an E right there. Don't forget that E. Oh yeah, there's a 10 right there. Don't forget that 10. Now, many of you will just get past that and you'll be on, but most of you should be putting that in there just to help yourself out. And then you start singing Meghan Trainor's song. It's all about that base, about that base. We're going to change it into an exponential. So 10 cubed is equal to x, right? The base, we write the base down, and then these things switch. Well, 10 cubed is 1,000. 1,000 is equal to x, and we are buddied. All right, that page is done. I think we're going on to some crazier stuff, so let me pause. I'll be right back. I'm sweating and still drinking coffee. It's an amazing addiction. All right, now we're going to get into some crazy stuff. Just crazy stuff. This is where, when you're out on a date, you say, hey, friend, why don't you try to solve that 1 for x for me? I'll tell you what, I'll give you my phone number. This is what, girls, this is what you got to do. You're at the bar, you bust this out. You say 4e to the 3x equals 1. If you can solve that round to the nearest hundreds, I'll give you my phone number. Now, here's why. 2, 1, 90% of them will just walk away. Probably not worthwhile. That one kid or 2 kids that can actually solve that question, they're probably going to be rich someday because they know how to solve logarithms, and they're at a bar or at a club or whatever. I say bar. You guys are too young for bars. I don't know why I said that. But if you're at a club somewhere out there with your friends and that should be the go-to right there. You can solve that one. You can have my phone number. Use it. Say, Mr. Krause gave me that one. It was cool. Anyway. You've heard me say this before. Got this from my partner in crime, Miss Newman. Get the weird thing alone. Do you know why she says that? Because we're weird and we're alone. So we always are used to it. But I want you to get the weird thing alone. Then I want you to undo the weird thing. Now, undoing the weird thing requires an inverse operation. Solve for x. And then this one is freaking-normous. Check for extraneous solutions. That's another word for crap answers. In order to do this, we're going to change form. It's called change form. Otherwise known as, you guessed it, all about that base, all about that base, all about that base. Would someone send this to Megan Trainor so I can get millions more hits from her? Maybe she and I can do car driving karaoke too. It's all about that base with logarithms and math. Oh my God, I'm thinking I'm going to make that video. I'm doing that video this year. I'm posting it. It's going to happen. And if you make one better than mine, I'm posting that one and putting it out there too. So if you can make one better than mine, which you probably can, we're going to do it. Miss Newman and I are doing this. It's all about that base. All right, there we go. All right. I'm so excited about this. Look, that's the project for all of you, to make a card karaoke of All About That Bass, singing Megan Trainor's song, but about math. It would be sweet. Okay, I think it would be fun. All right, so rule number uno, get the weird thing alone. This is the weird thing. What is this thing? Like if you said to your, the guy or girl that's asking for your phone number, hey, just tell me what that is. They'd be like, oh, that's okay. So we're going to get that weird thing alone by, remember, this is multiplication, so we're going to get rid of it through division. Divide by 4, divide by 4. Inverse operations, there it is. Multiplication, we get rid of it. So now what I have is e to the 3x equals 1/4. Now I can't stress this enough. If you have exponential, change it to log. If you have log, change it to exponential. And it's all about that base. My handwriting is getting worse because I'm getting more excited. We have an exponential. We need to change its form to a logarithmic. So wait a second, this is the natural base e. So in order to use the natural base e, I have to use the natural logarithms. All about that base. I'm going to write this base down here. Remember, that's not really necessary. So natural log base e, these two switch of 1/4 is equal to 3x. Well, I'm almost done. It says solve for x, so I'll divide by 3. Let me get rid of that arrow. I'll divide by 3. By the way, did I tell you how much I love these? Divide by 3. And there we go. That's what I'm going to type into my calculator. Now, don't forget, it's not going to let me type in that e. Natural log of 1/4. 1 divided by 4. Oh, come on, you son of a... 1 divided by 4. All divided by 3. It's going to make it look pretty when I do this. Okay, there it is. 1/4 divided by 3. And it's negative 0.46209. So x equals negative point... x equals negative 46209. 46209. Let me read the directions. Hundredth if necessary. X equals negative 0.46. 46. I'm telling you, I love this stuff. It is awesome. Okay, let's take a look. Here's our weird thing. There's our weird thing. We got to get it all by itself. Now, just like everything else, adding and subtracting them first, and then multiplying and dividing. So we're going to first move this 7 over. See ya? So we end up with 3e to the x equals 2. Then we're going to divide by 3. And we have e to the x equals 2/3. Now, we have an exponential. We need to convert this to a log function. This is the natural log, or this is the natural base, so we need to use the natural logarithm. So natural log base e, not necessary, but you can put it there, and then these two things switch sides. Of 2/3 is equal to x. Now this is what we type into our calculator, the natural log of 2/3. So control natural log, 2 divided by 3, ka-ching, 0.405, negative 0.405. So x is equal to negative 0.405. Round to the hundreds place, we go negative 0.41. Ka-ching. My answer key, I rounded to thousands place. Okay. So let me highlight it. This is the weird thing. And maybe it'll be more easier understood, is this is my base, and this is my exponent. So this is the weird thing right here. So I got to get that all by itself by getting rid of that 3. So I divide by 3. I divide by 3. So I have 2 raised to the x plus 6 equals 5. Now I'm going to have kids just absolutely freak out on this. Like, what? Not what? I don't get it. Sing the song. Sing the song. Sing it! Just kidding. Oh my God. I think I just scared my entire family. I'm going to have to record. My wife's probably going to come down and yell at me in a minute. I'll be back. I can't hear you. All right. I'm like the world's worst singer. Let me tell you a story. I was in chorus. Miss Judith Ranaletta. Anybody know Judy Ranaletta? She's in Greece, New York. She put me in chorus because I was 6 foot. I was athletic. I had hair. Yeah, at one point I had hair. I was an okay looking guy. Wasn't that ugly. I stood up there. She wanted athletic guys in her chorus to just make it look a little bit better. So she put these 2 powerful singers behind me and basically said, scream as loud as you can because we got to drown that guy out. His singing is so bad. That's how bad my singing is. If you were in my class, you'd know. Oh, wait, you're listening to me now. It's all about that bass, about that bass, about that bass. Okay, we have an exponential. On its route to solving, we need to change it into a log. So we're going to write the word log down here. It's all about that base, so we're going to copy over that base first, down here at the bottom of the G. And these two things just switch sides. Of 5 equals x plus 6. Well, to solve for x, I get log base 2 of 5 minus 6 equals x. And we'll type that into our calculator. All right, that's no problem. The log base 2, wasn't it base 2, of 5, oops, not 25, of 5 minus 6 is negative 3.678. And since we said round to the hundreds place, we're just going to do it right away. X equals negative 3.67, negative 3.678. Oh, 67768. And by the way, I haven't really been checking for extraneous solutions, but I should be. So one of the things, and well, actually, we don't have to check exponentials. I need to check logarithm functions. So we're going to check the next log function we have to do. All right, you ready? Wow, this one looks so bad. Like, when I put this one on a test, kids that don't listen to me are not prepared for this. Kids that listen to me think, oh, okay. Oh, yeah, I got it. It's an exponential. I got it. So don't freak out. I know this is an exponential. I know I'm going to have to change it into a log, in a special case, natural log. So let's get started. Let's get the weird thing alone. We're going to add 8. Add 8. So I get 3/4 e to the 3x equals 2. I still have to get the weird thing alone. Now, I get rid of fractions by multiplying by the reciprocal. 4/3, 4/3. These go. These go. I get e to the 3x. And if you put that in your calculator, it would just tell you that it's 8/3. Okay? So now we're almost done. We're almost done. We now have the weird thing alone. This is the weird thing. It is an exponential. In order to solve it, I need to turn it into a log. This is the special case. So just don't forget it's the special case. So you're going to sing it. Are you singing it? I don't have to scream at you this time? Nice. So in this case, it's going to be the natural log base e, and these puppies switch sides, of 8/3 equals 3x. Divide by 3, divide by 3. Now remember, this is not necessary really, but it's there to help us. So I come over to my calculator. I said, okay, the natural log of, what was it, 3/8? Divided by 3. Nice and looks pretty. Negative 0.33. So x equals negative 0.33. Did say round to the hundreds, didn't it? Hundreds. All right. I think we got we got 4 problems left. All right. These are log functions, so we're going to check these ones. All log functions must be checked. Okay. I actually have the weird thing alone because this is one big item right here. It should be in parentheses, but it's probably not, but it should be. So I want to turn this log into an exponential. Sing it. It's all about that base, all about that. So my base is 4. And then these two things just switch sides. 4 to the 6 is equal to 3x. Divide by 3, divide by 3, and I get, let's see, 4 to the 6, 4, 16, 64, 256, 1024, 4096, is that right? I don't even know. I'm going to check that. 4 raised to the 6, 4096. Oh, divided by 3. It's 4096 over 3. So x equals 4096 over 3. But it said round to the nearest. I'll just leave it like that. I'm going to check it. So what I'm going to do, the easiest way to check that is just store it. Control var, Control var x. It's frozen on me. Let me get back into it. Easiest way to do it is to just store that. So we're going to store it into x, and then we're going to type in the original function as soon as this thing pops up. My computer's running a little slow under this new update. Come on. I'm going to take this time to have a commercial about my favorite beverage. All right, my calculator's not coming up. So if it comes up, if it does come up, we'll check it. If it doesn't, we're going to be SOL for checking. But I don't know. It checks. Let's keep moving. Well, if it doesn't come up, I'm going to have a hard time doing these problems. So anyway, we're going to bring the 4 over. So I get log of 7x. Now, if you don't like the fact that the base isn't sitting there, write it in. Say, oh, yeah, that's base 10. Oh, yeah. Equals 1. Because remember, we're going to subtract 1. All right. Now, this one's easy. I don't even need my calculator for this one. So it's all about that base. So write the base down. 10. And these things switch side. So I get 10 to the 1 is equal to 7x. Well, 10 to the 1 is just 10. Divide both sides by 7, and I get x is equal to 10 over 7. I have no idea why my calculator is not coming up. All right, I'll be back. 2 problems left. So while I was on that 30-second break, I figured out how to get the calculator work. So what we're going to do is check our answer. And then we'll just check this one. X is 10/7. All right, so what we're going to do is we're going to take, I don't know why I keep doing that. We're going to take 10/7 and we're going to store it into X. So I do 10 divided by 7, control var X. And then I'm going to hit enter. Now, I keep doing that. All right, so log base. Let me put that in. Control log. Now, I don't have to put that 10 in there. I'm going to show you I don't have to put that 10 in there. Of 7x plus 4. Wait. Is that what the problem is? 7x plus 4? Let's see. 5. Ooh, that was nice. And notice that, oh, wait, look, I didn't put the base in there and put the base in there for me. So it knows that if you don't put the base in there, it's going to be 10. I'll check the next two, and then we'll be done. All right, let's get this weird thing alone. So we're going to divide by 2. Divide by 2. Divide by 2. So I get log base 7 of 1 minus 2x equals 6. Now, don't freak out. This is a log function. In order to solve a log function, we have to turn it into an exponential. That's really, truly the one thing you have to remember. And you have to sing the song. It's all about that base. So, base is 7. So 7, now these two things switch sides. This is now my exponent. So 7 to the 6 is equal to 1 minus 2x. Okay? We're going to subtract 1. Subtract 1. I'm going to do this in my calculator to figure out what this even number is. So 7 raised to the 6 minus 1. 117,648. So 117,648 is equal to negative 2x. I divide by negative 2. I divide by negative 2. And I get x equals, divided by negative 2, negative 58,824. Now, there's no way that answer is correct. I mean, it's just wrong. There's just no way it's correct. Just cross it off right now. But I'm going to check it anyway, just to make sure, because I know it's wrong, but I'm going to check it anyway. I'm going to store it, Control var x. Notice how it says answer, store into x, and then it replaces it with what the answer is. And I'll type it in 2 log, what was it, log base 7. Of 1 minus 2x. And we're going to get some probably error message or something. Oh my gosh, it's 12. It worked. Just because you get some ridiculously stupid, can't ever be right answer, at least in your brain, it's still right. Check it. Check your answers. It will crash on you if it's wrong. All right, last problem, last problem. All right, it's already got the weird thing alone, so we're going to change this into an exponential. And it's all about that base. So 3 squared, right? Remember, these two things are going to switch. This is the base. 3 squared is equal to 3x minus 1. We don't need a calculator for this, but we're going to check it using a calculator. So 9 is equal to 3x minus 1. We're going to add 1, so I get 10 is equal to 3x. And then divide, I get x is equal to 10 thirds. But we're going to check it. We're going to check it. So 10 divided by 3, Control var x. So 10 over 3 is x. And then we're going to type it in. Log base 3, Control log base 3 of 3x minus 1. And I'm crossing my fingers it's a 2. Woo! All right, kids. Take this time to thank your favorite Megan Trainor for giving us the It's All About That Bass song. Because if she didn't sing it, I would have had to make up my own song. It would have been really, 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 really awful. Hit the subscribe button. Hit the like button. More cool stuff coming. Keep going with this stuff. It's not that bad. And impress your friends and neighbors. Go home and ask your parents how to solve it. Yeah, Mom, math's hard now. Why don't you help me with this problem, Mom? You can't do it, can you? JK, kids. Bye.